So hey guys, welcome back to the channel. This is your physics buddy. In the previous lesson, we started forces and motion, that is unit 5 from honors physics curriculum. In this video, we're going to cover types of forces, apparent weight, and some numericals on tension. If you are new to the channel, make sure you subscribe for complete honors physics syllabus coverage. Like this video if you found it helpful later on. Let's get started.
So before moving ahead, there were a few things that we already discussed. Let us try to revise those things and then we'll move towards today's topic, that is apparent weight. So in this unit, we were talking about forces that do in one dimension. Like what happens if force acts in one dimension? And this is a part of mechanics in one dimension as well. So it all started with inertia. We talked about how inertia is defined as the integral property about mass. Mass not actually give us the quantity of motion possessed by the body, but it also helps us to understand the inertia of it, or you can say the inertial state. Sometimes it can be motion, sometimes it can be rest, and motion that too uniform, and sometimes it can be non-uniform motion. So all these things are, you can say, indicated by the inertia. It is a property of mass which actually define these three things. Also, then we talked about that what is the reason behind an object to move, that is force. This is the actual cause of motion. When we were discussing about kinematics, we didn't actually discover the cause of motion, but we discovered the cause of motion here in this particular section. So whenever there is a force, we understood from Newton's second law that it is directly proportional to rate of change of linear momentum. So before that, we already discovered what momentum is, and we described momentum as a quantity which actually helps us to understand the quantity of motion possessed by the body. So momentum is a quantity which actually represents what quantity of motion a body possesses. So that is represented by momentum. So according to Newton's second law, it says that force is directly proportional to rate of change of momentum. Like with what rate momentum is changing, that is something with what force will change or act. So when we remove this proportionality, we'll get K delta P by delta T. When we substitute the value of momentum, that is going to be V final minus V initial. And mass can be taken out common here. K is supposed to be 1, so we found force is nothing but product of mass and V final minus V initial over T. And if you understand, or if you remember the first equation of motion that we studied in kinematics, it says V final is equals to V initial plus acceleration times time. So this thing can be replaced by acceleration and we get force as mass times acceleration. So this is the very important, and you can say most of the problems from this chapter is solved by this particular relation only. So according to Newton's second law, the net external force acting on a system is directly, or you can say is equals to product of mass times acceleration of the object. So we just understand the cause of non-uniform motion, that is force. Because force ultimately produces acceleration and acceleration causes non-uniform motion. So after that, we'll discover types of forces. We started with understanding what is weight. And we defined weight as nothing but it is product of mass times gravity. Then we talked about normal reaction. So normal reaction is basically the force which is exerted by the surface back. So if there is a force of gravity acting on the object, because of which there must be some weight acting in the downward direction. And in the response to this weight acting on the surface, the ground or the surface also exerts some force which is supposed to be called normal reaction. In most of the cases, this normal reaction is equals to mg and we'll keep it the same. But here we have to understand that it is a normal force that actually acts on the surface, acts from the surface on the object in response to the weight. Then we talked about tension. So tension is a force which actually acts in strings, ropes, or even threads. Whatever we can say object you find which is long enough in length to hold up things, that object will experience tension. The most important part about tension is the tension always acts in pair. You cannot exert tension in any system without contacting the other end as well. So if you apply a force by just tying a rope at one end, so automatically you will observe that because of the external force, this rope must develop tension. And at any point, tension is always equals to this external force F. What we have to understand here is that this tension will keep on increasing till the time this force is increasing. And as soon as this force is more than the actual strength of the cable or the wire or the rope, or you can say the rope is not capable of withstanding that much tension again, this rope will break when this F much becomes much more than tension. Whereas if force and tension, they both are in their limits, they will keep growing together, like they will increase in in their magnitude together. This is the fun thing that we need to understand about tension. The next force we talked about is the drag force. And from this drag force only, we're going to get the terminal velocity. We'll try to find out that also. But first of all, let us understand what drag force is. So drag force is basically a force which acts due to presence of some medium. It is it will be only there if there is a medium. That medium can be anything. For us, this medium is air. So when we drop something from the ground and that thing has enough area so that drag force can act on it. So while going downward, because of this mg acting in the downward direction, this will also experience some drag force in the upward direction. And that is all because of the medium out here. This medium is causing the drag force to act on the object. And in our case, that medium is always air. So what happens here is, due to this drag force, the acceleration with which it is supposed to go down, which was initially supposed to be g, but now it has changed. So this acceleration becomes something else other than g, and we can assume it as a. So now it must be going downward with some acceleration a, which is not g. And what force causes that change? It is a drag force. So how we are supposed to find out this drag force? That is what we have to understand once again. As we know, according to Newton's second law of motion, net force acting on an object is directly proportional to rate of change of linear momentum or product of mass into acceleration. So here we can find out the net force. Now this thing can tell me in which direction this object is going, downward or upward.
Mm,
In which direction this object is going, in which direction it is moving, downward or upward.
downward.
So if it is going in the downward direction, so this is pretty much clear that the force acting in the downward direction would be more than the force acting in the upward direction. So the net force can be calculated by downward force minus upward force, which is going to be mg minus fd. And this is equals to ma. So from here, if you have to find fd, so it will go there, ma will come here, becomes positive, becomes negative, and this will give me the drag force. This is the force with which the medium is actually resisting the object to move. So that is something called drag force. But what important here is that you need to understand that how you actually apply second law of motion. It is F net is equals to mn. As I told you, this is the relation which we are going to use, like in the 80 to 85% problems, we're going to use this question, use this relation. So you have to understand the application part of this relation. That is the most important part.
Mm,
So the topic which you have to study here, first it was terminal velocity. So what is terminal velocity? So terminal velocity is the velocity with which any object in some medium moves with the constant velocity as force of gravity is neutralized by the drag force of that medium. So in order to understand what is this terminal velocity is, let us try to go to the basics once again. If the system is experiencing some net force, and if not, what are the cases that we actually figured out? If net force is zero, the object can be at rest. Similarly, if net force is zero, it can be in motion as well, but it would be moving with constant velocity. Or it cannot be zero. It means it must be experiencing some acceleration. It should be constant acceleration or variable acceleration, depending upon the force. So this is what we understood about the forces, balanced and unbalanced forces. So just try to understand this fact. If the object is moving, with a constant velocity downward. So the downward force, that is mg, is always balanced by the upward force, which is going to be drag force. So in order to find out the velocity of the object, what we actually do here is we just equate the FD and mg together. And whatever velocity we are going to find out, that velocity is going to be constant, and that velocity is supposed to be called terminal velocity. So that is the thing which we actually do in liquids. Liquids, as in, we suppose that there is a whole container, and we just uh, put something into the water. And what we are observing here is that because of that liquid, that object is going downward with a constant velocity, which is called terminal velocity. So the question is, how can we find this terminal velocity? This is find out using the drag force here, and in that case, drag force must be acting as a bind force, which is again a whole lot different concept. We don't go deep into it. If there is any problem related to terminal velocity came to you, just let me know. We'll discuss that question.
Yeah.
Although the derivation part involves some of the things that we actually didn't discover yet. So discussing that derivation at this point of time is of actually no use. So you just need to understand what terminal velocity is. If there is an object which is moving with a constant velocity, and that constant velocity is there because of the medium, or you can say because of the drag force acting in that medium, that
Mhm.
velocity is supposed to be called terminal velocity. That's it. Next thing we have to work upon is this term, which is called weightlessness. What is weightlessness? As simple as that. If accelerations becomes g, it becomes weightlessness. Weightlessness means you are not actually feeling your own weight. And when you are actually not feeling your own weight, when you are just came, or you can say moving with the speed of gravity, or you can say you are just moving under the influence of gravity during that free fall time, the situation you actually feeling at that point of time is supposed to be called weightlessness. So that is the simple thing. So you'll define weightlessness in this way, that if an object falls from great height during the motion of free fall, object doesn't experience any weight of it, any weight of itself. And that situation is called weightlessness. So I have used word object here, but that is something which is used for the humans, or you can say the real person. Because object, obviously, they won't feel their own weight. How they will be able to feel their own weight?
Mhm.
That is something which is obviously referred for the humans. And that is something which you can also experience in lift as well. If you are moving in a lift and lift is going downward. If you are in a lift and lift is going downward. So that downward, during the downward motion, you will feel a little lighter yourself. That is because of the acceleration, or you can say the speed of the motion of the object. Because in that case, you are actually going with the gravity. The lift is actually helping us to go with the gravity. And there is no such situation ever came to you that you are moving with the help of gravity or moving under the influence of gravity. You are always moving against the gravity. That is what makes us tough. But if you are going with the gravity, it might be a different situation, different scenario. So the next topic we have to understand or talk about is related to the lift part only, which is called apparent weight. So just like I told you now that when you're going in a lift in the downward direction, you'll feel a little lighter. Similarly, if you're going a little upward in the lift, you'll feel a little heavier. Now let's prove that terms or prove those things. So apparent weight. So first of all, what is apparent weight? Apparent weight is it is the net force experienced by any person when there's a net force experienced by any person when it is moving in a lift. So there are few cases. We have to understand those few cases in order to understand the conclusion of our words. So case one, lift moving upward. Always remember what, make sure that you remember what we just studied.
Mhm.
So there is a lift and this lift is going upward. with some a acceleration. That is what I can assume. Now there is a person which is standing on a weighing scale. This is a weighing scale which is kept on the floor of the surface of the lift. And there is that person standing on that weighing scale to identify whether his weight is going to be increased or not, or whether all our physics teachers lie. So what he does is he just went into the lift, standed in the on the weighing scale, and lift started moving upward. So if lift started moving upward, let us try to understand which force is going to be more. If it is moving upward, so this person must have some weight which must be acting downward, and that weight is going to be mg, where m is supposed to be the mass of the person. On the same point, as the weight is acting on the downward direction, the weighing scale must be applying a normal reaction, that too in the same direction of acceleration. If it is acting in the same direction of acceleration, we can say again Newton's second law of motion says F is nothing but mass times acceleration. So here the net force is going to be N minus mg, which is going to be ma. So N is going to be ma plus mg. So whatever normal reaction we calculated here, this normal reaction is actually the reading of the weighing scale. This is the reading of the weighing scale. So what you have to understand from this particular part, that weighing scale actually measures the normal reaction exerted by our body onto the ground. And there is the result of it, what normal reaction that weighing scale is going to measure, that normal reaction is supposed to be the reading of the weighing scale. So whenever we go to the market or just go to somewhere and try to measure our weight, what we did is we just keep that object on floor without motion. And even sometimes if you just look into your own weight by looking downward, doctor might say just look forward. When you must be kid went to the hospital sometimes for regular checkups, and when you stand on a weighing scale, you might be able to like just let me look myself. But sometimes it says that just look forward for the correct reading, because normal reaction might change as the position or the system changes. So in that case, you can simply find out that this n must have more value than the weight. So that is why in the first case, when the lift is moving upward with some acceleration a, it will be having more weight. Now the second case, the lift is going downward. So if lift is going downward, what is the net weight experienced, or you can say shown by the weighing scale? So what when lift is going downward? So again, we'll do the same process. We'll assume that there is a lift. The lift is going downward with some acceleration a. Again, there is that weighing scale. Person came up again with that same weighing scale. And when the lift is going downward, there must be some weight acting in the downward direction. And resulting, there must be a normal acting in the upward direction. So the net force this lift is going to exert is again going to be written by the Newton's second law, F net is equals to ma. So we simply say from Newton's second law, F net must be equals to ma. So F net can be written as mg minus n this time. Why mg minus n? Because lift is going downward, so the downward force must be greater in magnitude. And this is what it is. If the object is experiencing two forces, one in right direction, other is left, other in left direction, and we observe that the object is moving in the right direction. So which force is going to be greater, one or two? Tell me.
Mm, one.
So in the same way, if the lift is going downward and the person is experiencing two forces, mg in the downward direction, normal in the upward direction, which force is going to be greater? Mg, because object is moving in mg's direction. So the net force is written as bigger force minus smaller force. So bigger
Right.
force is mg, smaller force is normal in that case. So here mg minus ma is going to be n. So if we just observe it well, normal is going to be mg minus ma. Whereas in the earlier case, when lift is going upwards, normal is going to be mg plus ma. So automatically, in the second case, we will feel a little lighter than our actual weight. Next time when you use lift, make sure you try to observe this particular thing. That whenever you are going upward, will you feel heavy? Whenever you're coming downward, will you feel a little lighter? This will
Mhm.
not only help you to understand the phenomena, but you will actually remember the equations for so long. Otherwise, you'll forget as the time goes. Third
Mhm.
case, when the rope of the lift is cutted. During the case of accident, what happens? Acceleration of lift becomes acceleration due to gravity. So in that case, normal is going to be 0. And that is that is another same situation of weightlessness. So if acceleration of the lift becomes equals to acceleration due to gravity, in that case, we can say that the normal reaction or because of that person is going to be 0 because mg and ma both are equal in this part. So normal will be almost 0. So that situation is called weightlessness. Again, you get another, you can say different example here of weightlessness as well. But if you just let yourself fall from a cliff or fall during skydiving or in some other physical sport, so when you are actually falling through that great height, you actually feels that there is no weight. Your body is so light. And that situation is called weightlessness. So in order to achieve that state, we should be moving under the influence of gravity with the same acceleration that is 9.8. Although when we were even doing what we call it, like skyfall or whatever it is, we don't actually feel weightlessness completely because there is some drag force which actually causes this phenomena to not work properly. But if we need to feel it perfectly, we can go to some other planet where there is no atmosphere, we can feel it there. That is the case of, or you can say, apparent weight. These are the all cases. Let me just give you some problems. Try to answer these problems, and we'll see to understand each type of force. So first, not first, we'll see different questions here, and automatically we'll be able to understand what how forces are acting. So this will give a great idea about all and every type of force. So the question says, what is the tension in the string? Like what tension this string is actually experiencing due to this external force. This is what we have to understand and find. So as we can see in the image, there is a force which is acting in the system towards right. So tension must be developed in this part first, then in this part. As I told you, the tension always acts in pairs, so these two forces must be equal in magnitude. Now, as because of the tension and the force acting in the system, the whole system will start moving towards this direction, that is with some acceleration a. One more thing we can assume here, that the mass of each block is supposed to be m1 and m2. So now let us just try to form the equation of force, that is F net external is equals to ma. First, I'll write it for block 1. So try to observe the equation well. It is going to be F minus T is equals to M1A. Similarly, if I write it for block 2, it is going to be T is equals to M2A. How I came to this conclusion? Just try to understand what the forces are acting on block 1. F is acting in this direction. It is tension acting in this direction. The object is moving in the forward direction. The net force is going to be F minus T is equals to M1A because its mass is M1. Similarly, in the second object case, there is only tension acting in this direction. The whole system is going towards right with a acceleration. So here the net force is going to be ma, and net force is only T here acting in the right direction. So it is going to be m2a. So the tension in the string will be m2a. That's it. This is what you have to find here. Do you understand?
Mm-hmm. Yeah.
So the question says, show the tension force along with other forces. So here we have to draw the FBD only. And we have to show all the forces acting on this system. So let me start it with you. Tell me, which force should I mark first?
Mm. The the F. I mean, actually, the tension force.
The first force you have to mention is always weight.
Uh,
So weight is acting here in downward
downward.
direction M1, and
Yeah.
for this it is acting in the downward direction M2C. Second force you have to mention is normal. So normal reaction will be acting from both the surfaces, like from both the objects. For first it is going to be N1, for second it is going to be N2, like that. The second, after second force, the third force you need to mention is going to be tension. So tension always acts in the opposite direction of external force. As external force is in right direction, the tension must be in the left direction this way for M1 and this way for M2, like that. So this is how you actually represent all the forces along with tension acting in this system. Remember the order. First we'll mark weight, then we'll normal reaction, then the tension. That's it. Another question. Now this is something which you can easily do. What you can't do is actually finding tension. Showing tension in this case is not difficult, but finding tension is the case. Let us try to find tension in this case. In order to do that, what we are going to do here is, first of all, we'll try to represent the forces. So I'll assume that this whole system is supposed to be a one system of mass of sum of all three masses. And this is experiencing some force F. So here we know F net is nothing but mass times acceleration. So acceleration is going to be F by mass. And this mass is going to be M total. So it is going to be M1 plus M2 plus M3. What we have to do here is we have to find tension. How can we find tension? Let us see. So the first mass, as it is experiencing external force F, so tension must be developed in this case in this direction. And we can mark this tension as T1. Another end of the string will also experience same tension. Again, we'll mark it as T1. In the response to this T1, on the other surface, there is another tension developed because of thread and the mass. And we'll mark it as T2. So T1 and T2, they are the two tensions which will be acting in the system. And the whole system is supposed to move in the forward direction with A acceleration. Let us try to draw the FBD of individual blocks. And let us start with the first block. The first block is experiencing force F in the right direction and T1 tension in the left direction, and the system is moving, or the mass is moving with some acceleration A, which we already found. And the mass is supposed to be M1. So just tell me what should be the equation of force that we can make here, keeping the motion in direction in mind.
It should be to the right.
Yeah, what should be the F net equation?
Oh, F minus F minus T1.
For the second
How do
block,
you represent it? M1A.
yeah. For the second block also, it is experiencing these two forces, T1 and T2. The system is moving with A acceleration in the forward direction. What should be the net F net force equation? Tell me.
T1 minus T equals, T1 minus T2 equals M2A.
Correct. So this is my another equation. And for the third block, T2 is acting in this direction. The system is moving with the acceleration in the forward direction. So the T2 is going to be M3A. So if we substitute the value of A in this equation from this, so we get it is M3F over M1 plus M2 plus M3. So this is going to be the tension in the second string. Similarly, in the first string, if you have to find, it is going to be M2A plus T2. So M2A is going to be M2F over M1 plus M2 plus M3. Whereas acceleration is what? F by M1 plus M2 plus M3. So I just substitute the value of acceleration here. Where T2 is what? M3F over M1 plus M2 plus M3. So T1 is going to be F M2 plus M3 over total mass. This is the T1. What you have to understand here is the process, that how we are actually supposed to find out the acceleration. It's not that much difficult. It's very simple. You have to just keep one equation in mind, that is F net is equals to Ma. If you are able to solve and apply this equation, you can do any problem belongs to this particular section of the syllabus. Let's move ahead. Now this is another interesting question. Here we have to represent the tension at 3 points, A, C, and B. And we have to show the tension with other forces. So let us just show it. So at this mass, there must be some force that is acting in the downward direction, which is supposed to be mg. Whereas at the point B, tension must be acting in the opposite direction, like that. If we consider the C point as that, so the tension will be acting like that throughout the part. And the important part here is tension is going to be same throughout the rope. Tension is same throughout the rope until it experiences any knot or connection with other ropes. So this is the very important point about tension that you need to keep in mind, that how it actually acts and what are the ways it can change itself. Like for example, if this is a system connected with some roof, and suddenly what happens there is I just apply the force in this direction like that. So the whole system will move from its position like that because of there is some external force acting in this direction. And what it causes? It causes change in tension. Initially, it should have same tension, but now the tension at these 2 points has changed. If it is T1 in the first, or you can say the lower section of the rope, there must be some T2 tension in the upward section of the rope. This particular problem becomes the part of mechanics in 2 dimension, but this is also something which we can solve easily because the concepts and fundamentals remains the same, they won't change. So you need to just understand that how things change if the system changes, and this is the most important part about change in tension. So that is something I think I should not discuss, but this is only the one question that I am introducing here. Although in mechanics in 2 dimensions also we look upon these things once again, but as of now we just try to understand that how forces will act in the system. So here there must be mg that we should apply the very first. Now because of this mg there must be some tension here, T, and that tension must be here as well, T. Now because of this tension, as the rope experience some other ropes connecting with it as well, the tension will divide. So I can assume that T1 and T2 will be acting in these 2 ropes. Now try to look at the directions of the forces. This angle is theta. So this angle is theta. This T1 can be broken into components, just like vectors. So it is going to be T1 cos theta. It is going to be T1 sin theta. So T1 sin theta must be equals to T2, whereas T1 cos theta must be equals to T. So using these 2 equations, we can find out the unknowns if we are required to find. So again, you can keep this point, keep this particular question in mind. Maybe it can be there, maybe it cannot be.
Mhm.
But I hope this thing actually revises everything we did till now. Now here is the question, and you have time. You can try that question and let me know the answer.
Right.
Although this is the same question which we did previously, but that question we did in terms of, you can say, variables. But here it is going to be numerical values which you can use and actually find out the value of acceleration and tension. So just do it and tell me what should be the answer.
All right.
If you are able to do this question, it means that you understood each and everything quite well. First of all, try to find out the acceleration.
Okay. Is it 2 meters per second squared?
Correct. Find T1
Right.
and T2.
T1 is 40 newtons, and then T2 is
What is T1?
40,
Like,
40 newtons.
no. where you have marked T1 between A and B and B and, or B and C.
Oh, between A and B.
Okay. And what about T2?
B and C.
Yeah. What do you got for T2?
T2 is 80.
Correct. Well
Okay.
done.
Thanks.
So let's keep it till here for the class. In the next session also we'll discover some more questions related to all the concepts we have studied so far. Or you can
Okay.
say most probably apparent weight and all.